Hey everyone, thank you for joining to the Python study jam. And today, this is the last topic that we're going to cover from the Kaggle Python course. And we are going to talk about the external libraries. And let me, oh no, that's not. So for those of you who are new to this topic, this is maybe the first time you encounter this method, how to import, how to use libraries. But those who come to our Android development or machine learning study jams, maybe you're already familiar with Pandas libraries, with the NumPy, and maybe TensorFlow. So we have the we already covered with you how to create functions, and we could simply write the program without creating functions, right? To solve, for example, leet code problem. But we usually solve leet code problems by defining a function. And why we do this is when we define the function, actually we create a so-called function that we can use or reuse later. And we have some pre-built libraries that contain already defined variables and methods. Method is similar to functions that we can reuse. So maybe you've heard about the open libraries, open source libraries that already build the variables, the methods, and we import them to use them for our needs. So one of the basic or one of the most familiar library is math, and we can import the math library by using the import key word and specify the name of the library. And if we print this statement and use the dot format notation to print the type of the math library, we can see that the type is class, because we will cover about classes and objects in next our sessions, but shortly saying, class is a defined like a library, and we can create objects of the classes. And we have math, and then when we import math library, we can use its methods, variables. And if we want to see what's in this library, we can use the dir, I don't know how to pronounce correctly, function that lists all the variables or methods of this library. For example, one of the popular variable is pi. So if we use math.py, we can print the pi number, right? Or we can use the .log, which is the same method to the same format to access the variable or the method using the dot format. But pi is the value and log is the method. If we use the log method, we find or calculate the logarithm of the integer, for example, 32, which is 5. And if you don't know what are these variables, what are these methods, as we already encountered in previous sessions, you can use help function to see the description of these methods or variables. For example, here when we see that, okay, so we have, this is the format that we use our method. It receives two parameters. One is a integer and another is the base, right? And the standard base is natural logarithm, unless we specify otherwise, right? Other base. Here is the description that it returns the logarithm of x to the given base, and we see here if the base is not specified, it returns the natural logarithm of x. And you can see the description of the individual methods, but you can also use the help function to just learn everything about the library. So here's, if I click on this show hidden output, I should see the description of all these methods and variables. And if you don't have the link, this is the link for today's session. Okay, so there is another way to, not the way, but it's a common way to import libraries is by using the import keyword, specifying the name of the library, and then we use as empty. So Python, as I already described before, one of the maybe advantages of Python is that when you write the code, it feels like you're just writing an English statement, because what you write, you understand the meaning of this code. So if we say import math as empty, we understand that we import the math library as empty. So we save it as empty, like a short version. Although the math word is not so long, we want to get even shorter name, empty. And then when we access the variables or methods using the dot format, we use this shorter version empty.py instead of math.py. Yeah, like TensorFlow STF, right? Yes. And so I think this is maybe easy to understand. And if not, this is the another way to understand it. So we first import the library, and then we save this library as another name, empty. Okay, and we can import every function or method of this library using the star, and then we don't need to write the dot format. We just call the function by their names, like py, without like math.py, just py, if we import it using the star notation. And here, for example, we print py, and we find the logarithm of 32, same as above. But we should be careful when we import libraries using the star notation, because it's possible that, so there are many libraries already existing, and we can imagine that some libraries can have the same name for the methods, but methods can be different, right? So if we, for example, import the math and numpy, and then we want to print pi and find the logarithm of 32, we would encounter this error. And when we look at the error, we might be like, oh, what's that? I don't understand. First thing, just look at the final output, like the final sentence, and we see, okay, this is the type error. And what's the type error? Return arrays must be of array type. And I might not know what does it mean, right? So it's usually useful to just copy this phrase and then Google it. But I will try to explain what's going on here. Yeah, Abdullah, that's right. So because the way Python works, so it works from top to bottom, right? And when we imported the math library and then numpy, everything defined in numpy, which has the similar name of a function or of a variable as the previous library, will be overshadowed or overwritten, right? So it turned out that the numpy library has a log method, and this method is used for arrays. But the log method defined in math is used for integers. That's why when we use the log and then we specify 32 integer and then the base 2, we get the error, because in the parameters we should have the array. Okay, And I always encourage you to just use Google, and you can Google NumPy log. Yeah, and if you look at it, I think I prepared here. Oh no, this is another one. But you can Google NumPy log and then see the description, what it does, what parameters it should receive, what would be the output. It's super useful to start reading the documentation and start to understand it. And how to avoid these type of errors. One thing we can do is to import specific methods from the libraries instead of using the star notation. For example, from math, we import log and pi, and from NumPy, we import as array. And when we used, maybe when we covered the NumPy or Pandas library in machine learning course, we already encountered how to create the random number. So you already may be familiar with this notation. For those who don't know, there are also submodules. It means we will use dot notation 2 times because as this example illustrates, we can import the NumPy library. And then from NumPy library, we import the random module. And this random module contains other variables. For example, here we print NumPy random is A, and then we find the type of this module. And we see this is a class, right? Then we print it contains names such as, and then we print here the dir function that prints all variables, all the methods of the module random. And we have here the list of all modules, all variables and all methods. And one of these methods here is rand int. Maybe we don't see it here, but one of the modules is rand integer. This one, rand int. So we have here numpy dot random dot rand integer. So this rand integer is the variable of the random module, which is the submodule of the NumPy module. And as a result, we can see here, we have specified the parameters 1, which is the low bound, higher bound 6, and size 10. So it means we will print randomly 10 integers in the range from 1 to 6. This is the array. So we can confirm that there are integers no more than 6, right? Of a value no more than 6. And the number should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's correct. And here they say, okay, so there are many libraries, many classes, objects, and we already know about the integers, floats, booleans, lists, strings, dictionaries. At least we've covered them together. And I'm sure that I already see your progress, because last time we were, first time we were like solving problems, we could solve one problem. Now we can solve at least 3 problems, right? In an hour. So I already see your progress, and I'm super excited what you're gonna do in next month or next 2 months. So we already covered these topics, and the topic that we're gonna cover later on is related to these external libraries, or at least related to the class concept, the objects, data structures, algorithms. And they list here some tools to help you navigate through these unknown libraries or unknown data types. One of these tools is use type. Yeah, so we already seen that if we use this method type, we can see what's the type, data type of this variable, for example. And if we use the rows, which we define here, we know that, okay, so when we print rows, it's an array, and the exact type is NumPy ND array, n-dimensional array. Another tool is we already seen from this session is dir. And what it does, it lists all the variables, all the methods. And we already see here some underscore something, right? So that's interesting. What's that? And for example, when I use this method or this function to, when I apply this function to roles, I can see, okay, there are many variables and methods. And I picked the mean one and I tried roles.mean, and it will calculate the mean of my array. Then if I use the method to list, I can convert this array into list. And you could say, like, what's the difference? Seems like similar thing. I'm not sure about the details, but it looks similar. But if the difference will come when you try to apply different methods. So maybe last time you remember that if you try to apply one method to a different data type, you will encounter an error. And sometimes it's more easier to work with one data type than another for different types of purposes. So we should be careful when we try to convert one data type to another, because we should remember or use the function type to keep in mind what the data type I'm using and what can I do with the data type later on. The third tool is help, and we already saw this multiple times. It helps us to just understand what these built-in functions, for example, are used for, or what they return, and what are the examples. For example, we can use the help on roles, and it will give us whole information about all the variables, all the methods. And there is one concept called operator overloading, which might be confusing, but it just tells us about how different data types or how different libraries with their own variables and methods are defined and differs from another libraries. For example, if we just use the list and we try to add an integer, we will get the error. Can only concatenate list, not integers, to list. So they just explain us, okay, you can't add integer to a list. But if we use roles plus 10, we will get this result, no error. And the roles is an array, which is defined here. So this is our array, this one. And we see here the numbers are, so we know this is the randomly generated numbers from 1 to 6. And if we add 10 to rows, we see that each integer from this array was increased by 10. And why is that? It is because when the libraries, now built-in libraries, were defined, programmers defined the rules for each variable or the method, and it turned out that we can't add 10 to a list, but we can add 10 to an array. So this is one example. What's the difference between this and this? Seems like similar, but we can apply different methods. That's the difference. And this is other examples, what we can do with arrays. For example, we can compare whether the each item in our array is less or equal to 3, and we get the booleans. This basically what we did is we've converted, or we created an array that has booleans. Now here is the nested list. Yeah, so we have here a list, and the list contains sublist, right? 1, 2, 3, and another sublist 2, 4, 6. And if we want to create, so this is a list, right? And if we want to create an array, we should use numpy.asArray and specify the list that we're going to convert into array. And here is we print both the list first and then array. So here we say x list. So this is the name of our list. We use the square brackets as usual. This is where we paste the variable x list. Then \n is a new line character. So we should expect this will be our first line of the printed statement, and later on will be the second line. And the second line is the name of a second variable x. So this is our array. And then we create new line, right? And then we print the value of the variable itself. So this is x, right? And see the output. So x list is same, has the same appearance as we defined it here, but the x is looking like this. And you might say, okay, so I don't see any difference. Seems to me similar, just a nested list, right? But if we try to apply different methods to access the elements of this list or array, we would see what's the difference between them. For example, if I would like to use the square bracket method to access the item from an array, for example, 1 minus 1, I have the output 6. Do you understand why? If you have any questions, please let me know. And also, I'm interested, do you know why this would result in 6? How should I come up with this output using this method? So, okay, so I have here, yeah, 1 is second list and -1 last element from the list. Yeah, that's correct. So this is the rows, right? So we have here first row, and we know that we start from 0. So this is first 0 row, first row, right? Then this is the column. And we know from previous sessions that -1 helps us to get the last element. And we know that the last element is 6. So it's first row, last column. And if I try to use the same method, specifying the rows and columns on my list, I'll get the type error. And we have here explanation. List indices must be integers or slices, not tuples. So this is tuple form, right? And how to do it, how to convert it to slices, we should have just regular round braces. And I think the last thing is about just it's not necessary you should learn this today. It's just to get you familiar with different arrows or peculiarities of the libraries. So this is the statement that we already know. So this is the TensorFlow library to run machine learning algorithms. And we import this library as TF just to shorten the name. And then we use the constant method and specify 1. So we have here constant 1 and another constant 1 saved as B. And if we want to add these constants together, like A plus B, we get here, this is the outcome. Really strange, right? We would maybe expect 2, but not this list of something unfamiliar. And they explain that this is, why is that? Is because the TensorFlow doesn't provide you the math operations, but it will try to calculate it using the session method. So it's like, it will try to compute it using the running the machine learning library instead of just computing math operation 1 + 1. So it's just to show you that different libraries have different methods for even such basic operations like math operations for plus sign. And this is another example. So what they do is, so they specify the data frame. Data frame are accessed using these square brackets because we specify the columns and rows. And what they do is they access the column population, and they want only the population that is the values of a population from this column that is more than 1 million maybe. And so we know these operations, a data frame column continent, so only the values that are equal to South America. So we want only the rows that that belongs to South America with the population of more than 1 million. And so here they explain what is this underscore name. And this is actually the method that defines some methods that we don't even know we are using. For example, when we say like X in the list, this is actually available for us to use because we have a contains method that that is called to find something in a list. And it is written like this. It should be written like this, but we use this notation. So this is just a small overview just to get you familiar that there are libraries, we import them. There are different types of how to import, like method to import the library. And you should be careful when you import whole library or when you import specific modules, that there are some submodules and the operations on different data types depend on how these built-in libraries were defined. This is the thing, just to summarize what I have covered in these 20 minutes. And so this is the last topic, right? So if you do the practice, you basically should reach the 100% on this Python course and get the certificate. And I want to actually start the exercise with you all, just to get the first step, and then you can finish it yourself, or at least try to finish it. If you have any problems with previous exercises or with this exercise, you can write to any of our GDSC SOKENDAI social networks, or we can discuss it in later sessions. So as usual, let me share this link with you all. And every time we start with the first box of code, which just set up your environment on the web. And while it is set up, let's read the instructions. So here, after completing the exercises on list and tuples, Jimmy noticed that according to his estimate average slot payout function, so he has some function, the slot machines at the Learn Python casino are actually rigged against the house and are profitable to play in the long run. So this is some story about it. So starting with $200 in his pocket, Jimmy has played the slot 500 times, recording his new balance in a list after each spin. He used Python matplotlib library to make a graph of his balance over time. So from this short description, we know that there is estimate average slot payout function, and we should use this library. Yeah. So what we do here in the first block of code, we import something. And what we import, so we use learn tools.python. So this is the source. From this, we import Dreamy slots. This is the sub module of the learn tools Python module. And then he prints, so let's run it. Oh, we should define, oh, okay. Then he used the getGraph function of Dreamy slots that we imported to visualize his income or his result of his casino spins. And what we should do is here, we actually should define or create the function prettify graph. Maybe, I don't know why we have here a arrow. Shouldn't be any arrow. Okay, so this is the visualization of his casino something result. Okay, but this is just the background. Now what's the task? We need to help him, and what we should do, we should add the title to this graph, this one. We should specify x-axis to start from 0. Now it's not starting from 0, right? And we should add the label balance to the y-axis. And how we can do this? They give us some hints. First of all, we can type graph to get to know the data type of this method, right? Of this variable. And we see here it is matplotlib axis subplot something something. Okay, so it doesn't say anything to me. How should I proceed with these tasks, right? Then we see here, okay, they also say, that's a new one. We haven't encountered it before. I don't know nothing about it. Then let's say what we can do next. Let me comment this. Let's try to call data graph. And do you remember what should we expect from this? Actually, this dir is like directory, right? So it just prints the directory, what's inside our directory. For example, in my Mac, I can open Finder and, for example, open the document directory, dir, right? And I should see all the files, like other directories or variables like my files, documents, or Excel files. That's the same. Okay, so this is my directory. I can imagine just opening my Finder and see a list of files, okay? Okay, so I have here different methods, and then, okay, so we should try to focus on these 3 methods. This is the hint. This will help us to solve this problem. And then we should use this method to complete this function, prettify graph. And this is the, okay, that's a long list. This is the function that we should modify. We have here def keyword, the function name, and it will receive a graph parameter. And then, okay, so we have here the first task that was made for us. So we use set title method, and they already mentioned it here, set title. Let me delete this because there are many, okay. And we use results of 500 slot machine pulse. This is the the parameter. So the first step is done. This one is done. Now, how to make the y-axis starting from 0. And we see here, okay, we should probably use set while limit, right? Because while label, it seems to me that this is the solution for the third task. But I don't know what to write here in the parameters. And if I don't know what to write the parameters, we can ask help and specify the method that we don't know how to use, maybe like this. Maybe I don't remember. Okay. This is the library of graph. Maybe we should try graph. Okay, so I specified the variable graph here, which is of a type, this one. And I should specify the type and then the method, right? So I could maybe also paste this one here, but I'm not sure. Let's read. So this is the set while limit method that can potentially have these number of parameters. So we can define them all or define some of them. And let's see what these parameters mean. So the first one is bottom. This is usually float, and this parameter is optional. So it means we don't need to specify it all the time. Okay, then what it does, the bottom while limit in data coordinates, passing none leaves the limit unchanged. The bottom and top while limits may also be passed as the tuple. So we can here, instead of none, we can have here tuple, the round brackets. And it seems to me this is not the, maybe the solution. Let me just read it, another possible parameters. So we have here top, similar to bottom. The top while limit in data coordinates, passing none leaves the limit unchanged. Then we have emit, which is a Boolean, whether to notify observers to limit change. Okay, so this is just, if we say true, then we will get the message that our limit has changed. We can have here parameter auto, which can be Boolean or none. And the default, okay, so here default is true, here the default is false. Let's see what it does. Whether to turn on auto scaling of the y-axis. True turns on, false turns off, and none leaves unchanged. So if the auto parameter has the default false, then it means we don't have the auto scaling of the y-axis. I already see that these parameters we won't use. Let's see next, y mean and y max. This is the float, and this is the optional parameter. They are equivalent to bottom and top respectively, and it is an arrow to pass both y minimum and bottom, or y max and top. So what it means is that if you specify bottom or you specify top, you should not specify y min and y max respectively, because it will cause an error. And it means to me that, okay, so for example, I'm not sure, I think I should specify either bottom or y minimum, right? To specify the 0 as a y-axis starting point. But maybe I'm not that sure. I'm not so experienced. Let's see next. And we know that it will return something. It will return bottom or top, the new y-axis limits in data coordinates. Oh, okay. So here I see the confirmation that I should use bottom or top to specify the y-axis limits. Okay, but maybe I'm not that sure still. And here I have some other information, and I have here the examples. So I can have the example how to specify these y-axis y-axis limits. For example, I can have here set y limit 500 0, and it will specify 1,000 right meter depths as the bottom of the plot, and the surface 0 meter as a top. So what I can try here, I can use graph set y lim, and as a parameter, what do you think should I write? So we should have y-axis start at 0. So it means bottom or top, y minimum or y maximum.
Minimum.
Let's try minimum, right? Let me see. Okay, so I don't need to write actually. Okay, I need to specify what type of parameter I'm trying to parse. So I say 0, and let's try the third task as well, and then check the answer. We need to add the label balance to the y-axis, and we already have the hint that we should use this method. So I'll just copy it. Okay. Set y label and specify here balance, right? Because we need to specify the label balance. Okay, then let's run it and see if we got any problems. Okay, so I think there is no problem. We have here y0 is not specified. Is it the same? Yeah, it's the same. Oh, I see. I see. So I just I was confused because previously I confused y-axis and x-axis. I said to you it starts from here, but this is the x-axis, right? So we should look at the y-axis. Previously, y-axis was shifted upwards, right? So we have here 150, and we need to set the minimum to 0. That's why we have here 0, and our graph is like shifted above, right? So we have here the right output. So we've solved this problem together correctly. And I think we will stop here for this exercise. And I'll let you try the bonus task yourself, to solve yourself. And here is also a little bit maybe more complicated task to solve for you, but I encourage you just to try, just to read it, try, experiment with code. And if you have any questions, any problems, I'm happy to explain, help you, or give you directions. And you can get the certificate and share with all your peers, your friends on LinkedIn. And this is it for the Kaggle final session. And somehow we have not so much time, but I also prepared the Titanic tutorial. So Jimarao asked me a question just before we started this session. How can we use Python, right? And actually I prepared today this tutorial, how to perform a simple machine learning, training and prediction to understand what who survived or who died in the Titanic disaster, or the, so we have here the data, we have here the code that we can use, but because we have not so much time, I think if you want, I can try to explain it fast, like quickly. Would you like to spend it next session some time to understand it, or would you like to try to squeeze it into this session? Okay, maybe not difficult to say. We don't want to solve it today.
Yeah.
Okay. The only thing that I have to say for today, then we will stop this session here, and I'll see how it goes on my side to start this course. This is the short-term goal for us. So we are finishing the Kaggle course today. And I hope you'll do your exercises on your own and you got the certificate. And we are starting the object-oriented programming in Python. And we're gonna create adventure game, our small project. This is the next step in our Python journey. And I think that's it for today. If you have any questions, any suggestions, let me know. I'm always happy to the feedback. And otherwise, this is it. Thank you.
Thank you very much.
Thank you. Bye-bye.
Bye.
Bye.